Do you want to run image generation? Do you want to train a custom model for object detection, object segmentation, pose estimation? Do you want to run LLMs right on your machine without using any external service? So here, as you see, it's completely offline LLMs running on my machine. Hi, I'm Sergio, and we're going to see everything right now. In this video, not only we're going to see some basic parameter of what you need to get in terms of RAM memory or in terms of graphic card, but most important, we're going to do some tests and show some benchmarks on different type of models, whether it's image generation, object detection, segmentation, and so on, so that you know what you get when you buy a specific hardware and you don't either spend too much on a hardware that you don't need because it's an overkill, it's more than you need, or either you go too cheap with your budget and you buy something that's not powerful enough for the work that you need to do. So it's very important that you understand the difference on the components that you buy based on the work that you need to achieve the goal that you want. Now let's get straight to the point. There are two things that you need to take into consideration, the most important ones. The first one, the GPU. So the first one is the graphic card. What graphic card? NVIDIA. Do you want to use AMD? Yes, you can. Will that make your life harder? Yes, it will. So go for NVIDIA because NVIDIA has the framework CUDA, which is the most compatible, most up-to-date, the fastest, and that's used for deep learning. So when we are about graphic card, there is one choice and only one, and it's NVIDIA. What's the second thing about the graphic card? About the graphic card, a second aspect to focus on is the VRAM. So how much memory, which is not the same as RAM. So one is RAM. Let me write it here. The RAM is the RAM memory in the computer. The VRAM is the video RAM memory of your graphic card. So if you're on Windows, you can just open the task manager, and if you check here, on performance, you will see GPU and you will see dedicated GPU memory. That's the VRAM memory that your graphic card has. In this case, I have 24 GB. NVIDIA, how much VRAM do you need? Well, not less than 12 GB. 12 GB is the minimum that I recommend. Can you run things even on lower memory like 8 GB? 6 GB? Yes, you can. I have a laptop with the GTX 1660 Ti with 6 GB. I can train some model for object detection. I can run object detection, but it's very limited. So if you're on a very, very tight budget and you can't get more than that and you want a machine, if you can afford 6 GB, you can do still a lot of stuff, but you will encounter soon a lot of problems. So if you can afford 24 GB, go with that. A good range is 12. There are graphic cards from 12 GB, even 16 GB, all the RTX 40 series. There are new cards with 16 GB and so on. How about the RAM memory? RAM memory at least 16 GB. Don't take less than that because you're going to run out of memory. 16 GB or more, and here also. Ideally 32 GB, and now I have 32 GB and I feel it's still very limited and it's going to take a lot of cache memory. So if you can afford 64, 128, not less than 16. If you want to find a good ratio, let's take 32. Ideally, yeah, between 64 and 128 GB will be the ideal, especially if you want to run LLMs. If you want only to run with object detection, object segmentation, and all these kind of projects, you are good to go with 32 GB. If you want LLMs and if you want also image generator and so on, the more RAM you have, the better, of course. I will not get into details about CPU and so on or how much memory, but I will give you some general ideas. So you want to have at least a 6-core CPU, at least. CPU with 4 cores that sometimes they have on laptop are very limited. So if you want to run multiple videos at the same time, then the CPU might not be able to leverage the graphic card to a certain point. And then the hard drive, it's important that you have a lot of memory because the models are very heavy, especially if you download language models, if you download image generator models, they are like 10 gigabytes, 20 gigabytes. When you want to make training, often you need large data sets, and like data sets can be 20, it can be 50 gigabyte, can be 100 gigabyte, and it stacks up very quickly and you have no more memory. So I recommend at least 4 terabyte of memory. If you are on a laptop, usually sometimes they have 2 hard drives, so one can be 1 terabyte, at least the main hard drive, and then you can have a second hard drive with 4 and plus terabyte. If you have only 500 gigabyte or 1 terabyte, it will be very limited. You will need to remove stuff all the time to make free space for new models and so on. So keep everything in mind when getting your next machine. If you are struggling with memory, you can also get an external drive. That can be an option. But again, most important is GPU and RAM, because with a slow CPU, you can run things slow. If you have the wrong GPU, if you have not enough memory on the GPU, it's not that it will run slow, it just will not run. So keep this in mind. If computer vision is more than a hobby for you and you want to build projects, you want to train a custom model, you want to launch your computer vision startups and you don't know how to do, you are struggling, you want sources that can help you do this in the fastest and most efficient way, I'm launching a community, pysource.com/community. For the launch, I'm going to make a huge discount that you can get advantage if you join in the list below, and I can't wait to see you there. Now, let's get back to the video. Let's now test a few things on the RTX 4090. So I'm now running object detection and we see that we're getting around 200 plus frames per second. So I'm now running the YOLO version 8 medium model and we're getting a great performance, 200 frames per second. At the same time, let's see how much we're using of this graphic card. We're using around 60% of the graphic card. So it means that the code could be slightly more optimized, while also we can run multiple videos and getting still 200 plus frames per second. So imagine that putting 2 videos, we can reach around 400 frames a second on a single machine with the RTX 4090. This means that you can run many videos. You can run like 5-10 videos. With 10 videos, you can get around 30-35 frames a second. So with such machine, it's like having a small server where you can run CCTV cameras for detection, for people detection and so on. So if you need only to do object detection and you need to perform this only on a few videos or at the same time, then of course the RTX 4090 it's an overkill. You don't need so much power because normally we need 30 or 60 frames a second. So object detection, you can do it pretty much on any card, even with 6 GB or even 4 GB of video RAM. So for inference, of course, you can use also very small devices. I have now one at the back. I have their NVIDIA Jetson Xavier devices that cost a few $100s and they can run object detection with the Xavier. This model will take around 60 frames a second according to my tests, but with smaller model you can get even more. So I'm running the YOLO version 8 medium. And how about the training? Here I have a notebook where now it's already ready for the training. So I'm going to start to show you some benchmarks. What I have here, I have 113,000 images. This is a data set to train vehicle detection in any condition of the day. So that's why we need like night data set, days data set, different conditions. So that's why we have also so many images. 113,000 images. We have now the training running. We're going to run 50 POCs to complete the training, and each one is going to take around half an hour. So if you see, each POC is made by 5,600 steps around. And if we do the maths, we get around 25 hours. So in 25 hours, we complete the training with this machine for 113,000 images. So it's a very big data set, and despite that, in only one day we can complete the training. So this is a very fast card, and normally you might have a much smaller data set than this, like 10,000 or 20,000 images. So it will take much less. So ideally in like 6 hours you can be done with your training. There is one thing that that it's important to know. Now, there are different YOLO models. You can see YOLO V8 Nano, small, medium, large, extra large, and the difference is the accuracy, so the speed. So the faster is in the speed, the small is in accuracy because it's a smaller model. And we can understand the size of the model based on the parameters that they have. The smallest one is 3.2 million, where the biggest one is 68.2 million. So like almost 20 times bigger in size. And we tested before the YOLO version 8 medium, which for the training was taking around 9 gigabytes of memory, and it has 25 million parameters. Let's now see what's the difference when training the biggest, the extra large model for object detection on the same data set. So right now we see that it's taking, of course, much longer. It takes double the time for the training. Instead of 30 minutes for each epoch, is going to take more than 1 hour for each epoch, while at the same time it's taking 13 gigabytes of memory from the graphic card. And you need to consider that in addition to this, if you have only one graphic card, there are other things that on your computer are going to take memory into the graphic card. So you need to have some extra space in the graphic card, so it doesn't need to be tight. And this means that if the graphic card is less than 12 gigabytes of memory, here you cannot run. So the minimum here, you will need at least a 16 gigabyte graphic card memory, like the RTX 4080, 4070, if I'm not wrong. Also for image segmentation, I don't have data sets here for the image segmentation to test it in this exact moment, but I use it in the past. And for image segmentation, again, you need to have at least 12 gigabytes of graphic card to train the medium model. Now I have a second machine with the NVIDIA RTX 3060 with 12 gigabytes of VRAM, and I'm testing the training on a similar data set. So with 100 plus thousand images, and the training again for 50 epoch, it takes double time. So this is now the YOLO version 8 medium, while the RTX 4090 was showing us around half an hour, 35 minutes. Here it's showing 1 hour, 20 and plus, because this card is not only smaller in size, but it's much weaker than the RTX 4090. Also, the difference in price is quite big. At the same time, we can train the model. So this card is great because probably doesn't make much difference if your model takes 6 hours or it takes 12 hours or 15. You can leave this training at the night if it's the only machine that you have, and that's pretty good. Anyway, normally you use smaller data sets, so it's not a big deal to train the model even with this graphic card. So this graphic card for object detection is pretty good. If your only goal is to work on object detection and nothing more, go with the RTX 3060 is the best buy, nothing more with that. And let's now try the image generator. It's one of the most exciting things I've been playing around with lately, and it's amazing, it's incredible how you can generate such realistic images like this one right on your machine offline. So your computer can generate any image, realistic image, without being on the internet, and I'm still amazed by this. So let's put some command of anything. A dog running in front of a pyramid. It's sunny. What else can I put? Let's leave it like this. And of course, for image generator, the more information you give, the better for the quality of the image. Now it's only for testing the speed and so on. So what it happens now, the model is loading into the memory. So the first run, it's always slower. So it's normal now for this to be slow, and later on the second runs, it will be much faster. So let's now compare, of course, take into account that now it's the first run, it's loading into the memory, and now it should be started. Okay, now it started processing. You see it's already 25% of the images. So in total, it takes, I would say, around 15 seconds or less to generate the image. And look at the image. Look at what results we are getting. Let's now play around with other images. Also, let's increase the size, because one thing is also about the bigger the image size, the longer it will take to generate. So this is a vertical image. Let's now generate a full HD image, 1020, 1920, and 1080. So this is full HD image. Also, there is the sampling. So the more sampling steps you do, the longer it takes. Normally with such model, I'm using Flux. The model, it takes from 20 to 30 steps. Let's now generate something else. Instead of a dog, let's say a cat on a building with an NVIDIA graphic card. Does it make any sense, this graphic card? But let's see. Let's see if we can get some real image for this generation. Now again, the model should be loading into the memory already. Probably when I change the specs, it's running again, I'm not sure. As you see now, it's definitely slower, not much slower, but slower, because we have a bigger size image, and that's why it takes longer. And also more sampling step. So you need to keep this in mind, and wow, that's amazing. You need to keep this in mind when you run services offline, that the more you increase this, the more you pay. So it's great when you do it on your machine. If we had to, if we had to generate these images on a server using the API, we would pay around 4 cents of dollar for each, or 3 cents, 3.5 cents of dollar for each image generated. And this is the result. So we got an HD image of this cat with the NVIDIA graphic card. So I wouldn't expect to have like such a realistic image for such unrealistic scenario, and it's amazing to see this. Let's now try. So this is with the RTX 4090. Can we run this on the RTX 3060 with 12 GB of video RAM? Let's try that. And now I'm testing the same model on a different machine. I have now the RTX 3060 with 12 GB of video RAM. And to be fair, I'm testing with the exact same parameters. So full HD image, 1920 by 1080 and 25 sampling steps. And as you can see, it's very, very slow in comparison with that. And if the other one was taking 25 seconds, now it's taking a few minutes already to generate the image. Because the memory, it's very low, so there is a lot of time wasting swapping the memories and using the GPU. So can you run this? Yes, you can. Is this efficient? Absolutely not. This is not efficient at all, and so I wouldn't even recommend to run such model if you need to use it for work. If you want to just to test, to play around, if you want to have fun, then it's fine. But if you need to work with this, then it's slowing down a lot of your progress and your process. So it's much better to just rent this online, where you pay a few cents for each image generated, or to rent some GPU online where you pay $1, $1.5 per hour per the GPU, so that you can be very fast. Because if you play with this and it takes you 1 hour to generate 10 images, then you're going to waste a lot of time. If you want to test things with a good graphic card, in 1 hour you generate a big amount of images and you can work much faster. So 12 GB for image generation, especially with such heavy model, I absolutely don't recommend that. The total processing time to generate this image right here was of 3 minutes 40 seconds. So you can see how inefficient this is. Of course, you can increase the speed by using a smaller model, like less precise model. You can decrease the image resolution. Instead of full HD, you can use just HD size. So there are many things that you can do. You can also do some improvement on the settings right here. We have a few things about memory of the GPU. So there are things to improve it, but still it's very, very inefficient. And now, as last test, let's run the the text generation model. We have here Llama 3.1, which is open source from Meta. And the great thing is that we can run this on our machine. There are multiple models, from the smallest one to the biggest one. And of course, we cannot run the biggest. There is a huge difference in parameters. So the smallest one is 8 billion parameters with 4.7 GB of memory. We have the 70 billion parameters, which is 40 GB of memory, and then 405 billion parameters, 229 GB of memory. So this 405 must be only, unfortunately, run on a server. We cannot run that. We can for sure run the 8 billion. Let's say, hi, tell me a joke. Here is one. What do you call a fake noodle? An impasta. Of course, this is a very small model. If you are used to ChatGPT, Claude, or other ones, you will see that this one is not so great as the other ones, but you can have this offline running on your machine, which is great. So if you have to do some task where you don't have internet connection, you can use this and like some summary of some stuff. You need to ask some questions, like some research. This is a great model. Very small also, so this can run on many graphic cards. It's taking around 8 GB of memory on this graphic card. So if you have 10 or 12 GB VRAM on the graphic card, you can run that. You can also run this if you don't have a graphic card on the CPU. If you have a Mac device with a good amount of RAM, this will run. Let's now try the 70 billion parameters. We have like dedicated GPU memory. It's almost all the memory is full. I have only 32 GB of memory, which is not enough, definitely. So for the specs that I read, is 128 GB of memory recommended of RAM memory, and I have like only 32, and it's taking also a lot of cache memory. So because the RAM is not enough, so they need to take cache memory 60 plus gigabyte more of this. So I'm expecting a terrible performance. Let's ask Llama what are the PC requirements to run Llama 3.1 70B. So we ask the model what are the requirements to run the model. It's thinking very, very, very slow. So extremely inefficient. I hope that this video was useful. Please, if you like this and you want to see more, you can subscribe to the channel. And also, I'm launching soon a new community. And if you sign up, here there is the waiting list, pysolve.com/community. For the first users that they will join, if you will join, you will have a great launch discount. So make sure you stick around to take this great advantage, because I will do this launch and discount only once when I'm going to open the door to this community. So all the links, information down below in the description. This is all for this video. See you in the next one.